All right, so we are here with Vasapal. Why don't you give us a quick rundown of what we're going to be talking about?
Hello everybody. Thank you, Brad, for the invitation. I'm really excited about joining Global XR Conference today. So yeah, what we are talking about is mainly about the human-machine interface and what we expect to have down the road in order to create a more realistic way to interact with the virtual world. So today I'm gonna share with you my experience on that field, what we are trying to build with my team, a solution that is gonna make more realistic the way we feel and touch the virtual world. And we think it's gonna be a leap down the road in human-machine interface.
Very cool. Okay, and what's your background? How'd you get into this?
So yeah, that's let's say a complicated story. Since I started with business studies, but from the very early days I realized that I want to deep dive into technology. So my master and also my professional career followed that direction. I've been worked for a software house like SAP, mainly involved in the flagship product S4HANA, but it's in memory computing. And I followed a career in consulting, working for Deloitte and the business technology department. And from the early days, I realized that I want to create something from scratch, actually to create something that is meaningful for the market at the same time. So that's why I started participating in several hackathons and competition back in the days. And that's why we ended up to Magos solution. And approximately 4 years now, we work on this endeavor. And I think it's something interesting from several perspectives, and more than welcome to share with you my experience on that.
Very cool. Very impressive. All right. Well, let's get started then.
Thank you so much. So once again, my name is Vasilapostolos Uranis, and you can call me Vasapo for your convenience. I'm born and raised in Athens, Greece. At the moment, I'm doing a visiting scholar at St. Louis University, where the university is interested in adopting our technology in several applications from healthcare, aerospace, also computer science. More than welcome to share with you more about that later in my presentation. And as I mentioned, my background comes from several sectors, but mainly in business to business, trying to solve real problems that corporates out there are facing. Today, I'm gonna share with you my experience and my background in emerging field, let's say, the human-machine interface, especially in the world of extended realities, trying to create that something it's not new from, let's say, research point of view, but we think that the time has come, let's say, in order to create something that can push the not just the adoption of extended reality technologies, but in order to support this transition to the adoption of these technologies in a more meaningful way. The title of my presentation is Touch the Intangible, and we are going to, let's say, conclude with a question to ourselves if we will manage to feel and touch the digital world. So starting from the very beginning, the let's say what's the problem statement here? Uh, if we take into consideration the latest, let's say, developments in the extended reality technologies in the metaverse world, we see that the most, let's say, the two most important senses like visual and audio, the current technologies out there support the simulation of these two senses in a very good level. We see great companies like Vario that provide a very good resolution and displays that can recreate and simulate the observation of the virtual world very good. And at the same time, the developments in the 360 audio also come to even more immerse your experience inside the virtual world. However, while we have this good immersion in these two senses, when it comes to do with interaction with our hands, then the VR controllers, the standard solution out there, does not provide the same level of immersion as we see and hear the virtual world. And that's why we try to create a solution that can simulate, let's say, the sense of touch in a meaningful way. Of course, we see a lot of solutions out there that and really sophisticated solutions that try to simulate the sense of touch. However, we see some technology limitations in all these endeavors. Uh, the most common, let's say, application out there is the camera-based solutions, like the Quest 2 hand tracking. We see that also this offering from Quest 2 is pretty nice, and we see progress the last 2 years in the hand tracking aspect. However, all these solutions that are rely on the, let's say, the optical tracking the inside out tracking from the cameras that are mounted on top of the headset, are facing a very serious, let's say, problem, which is the occlusion effect. When you place one hand below the other, you cannot track one of the hands. And when you want to collaborate with your hands, also this is another limitation that you face while you are interacting with virtual world. So of course, this type of technology is something that it's pretty, let's say, very good in terms of portability, because you don't need to purchase or to get with you another component. However, when it comes to do things in a natural way with your hands, and the precision and the reliability is important, these type of technologies provide some limitations. So that's why we developed 4 years now the Magos technology, which is a combination of hardware and software. And I will try to provide you more insights on how we managed to create a system that can simulate not just the tracking, but based on the tracking technology, to be able to create in a more meaningful way the peripherals, like the passive feedback that comes from tactile and kinesthetic feedback, in order to simulate in a more meaningful way the sense of touch. So, Magos, in its heart, is a mechanical approach tracking that can provide very high reliability in the tracking of every finger joint. And this is the unique value proposition here. What we see in the market out there is that, and also in research, that there are solutions that uh, can track some points in the virtual in the physical hand, and based on these points that they can track based on their position mainly, they utilize inverse kinematic models in order to guess where the rest of the hand is placed, and the motion of the fingers are performed during the operation in virtual reality. What we do is we manage based on the hardware to track every finger joint isolated. We track all 16 joints of the human hand that can provide 22 degrees of freedom. That means that we can track both vertically all the motions of the on the joints, but at the same time also the horizontal degrees of freedom. This is really important because this mechanical approach, along with the algorithm that we have developed on the application layer in order to get advantage of the mechanical exoskeleton, provide us to reach up to sub-millimeter accuracy. And that means that we can interact with objects, virtual objects that have this level of thickness, which is really important when it comes to very detailed interactions, like interacting with medical equipment for surgical training, let's say. So, on what happens here? Since we have this level of accuracy, there is a great opportunity in order to trigger now passive feedback in a more meaningful way, because we know where every fingertip is placed within a virtual world. And if you grab a knife for surgical training, so at the same time, since you have this level of accuracy and you have this information, then you can trigger the haptic and force feedback in a more meaningful way. And this, as you can understand, advance the level of immersion inside virtual world. And I have to say that this is the baseline, because on top of that, we take advantage of Magos SDK that we've developed in the two most common game engines out there, like Unity and Unreal, that actually this level of sophistication in tracking enable us to take advantage of the physics engines inside these game engines in order to make even more immersive the interaction with virtual objects, because now we can apply physics in the interactions like friction, weight, and we can create libraries based on this interaction. So when it comes to develop applications or to integrate our solution into existing application, you can take advantage of these libraries, and you can easily transform your current solution based on VR controllers into our Magos exoskeleton. And this is really important about the adoption, and not just the adoption, but also about the community that is going to use our technology to develop application with ease, and at the same time to get the maximum outcome in terms of realism. And here you can see the difference. Actually, on the left side of the screen is a typical interaction with a virtual reality controller. You can see how you can grab the virtual laryngoscope for intubation practice interaction. The end user has to place the controller at a specific place, position, sorry, and then has to press a specific button in order to grab the laryngoscope and then perform the operation. While in the right side of the screen, the end user can take advantage of the high accurate tracking, as you can see, and grab the laryngoscope and at the same time feel through the haptic and force feedback the virtual laryngoscope. And this is not just about the operation, but we've seen, especially in virtual training and simulation application, that this transition from the static or weird, let's say, interaction with the controller, our solution can support the muscle memory required for such training applications. Moving on, as you can imagine, a solution like this comes to advance the outcome in terms of like user experience in several applications, like the healthcare that we just saw, of course, in gaming. Also, we collaborate with aviation partners in aviation industry and also in space. So and of course, we see very interesting use cases in the robotics. Uh, Now, I would like to share with you a video that provides a very good understanding about the level of accuracy and about every finger joint that I mentioned before. That we can track every joint isolated in order to create a very reliable digital twin of the human hand. This is a beta version prototype. That's why there are some words around there, here and there. However, at the moment we are trying to complete the beta version, and we expect to proceed with the first shipments in 1 month ahead. And now I would like to share with you some use cases that we collaborate with some organizations around the world. This is, as you saw before, an intubation practice procedure. So we collaborate with the University College of Dublin, and we have created similar applications for other departments of the hospital. You can see also here how we interact with, as I mentioned before, with very tiny objects that vary the thickness of their width. It's pretty small. And you can see also the physics that I mentioned, how when you grab it and you press the tool, you can see also the physics interaction with the virtual object. That not a typical snap based interaction with the virtual object, and this is a game changer on how you experience the interaction, getting advantage of such let's say dynamic way based on physics game engine. And as I mentioned before, this is something that we try to create a library in the Magos software development kit in order to easily apply to every interaction that we have to create in the existing applications out there. Now you will see a cockpit simulator application that we've developed with our partners from Denmark. and our partners from Berlin, Breakpoint One, that they have created this cockpit, and based on our software development kit, they managed to create all the interactions pretty easy. Um this is something that it's uh, provides, as I mentioned before, compared to the interactions with VR controllers. The feedback from the industry is that a solution like this can support the muscle memory required for pilots to to understand better the operation and to be more close to the real procedure that they have to follow in a real environment. So this is really important because at the end of the day, we can minimize the time needed in order to create and perform this type of training for these people. And as you can see now, this is really important when it comes to even more difficult interaction like thrust levers that you have to interact, or very small rotating buttons that this type of interaction it wasn't possible with other solutions out there. Here, I will share with you, before concluding my presentation, some use cases in the robotic industry, but also in some of them, we take advantage of extended reality technologies. I mentioned before that our accuracy is pretty high, and that was really important for teaching robotic systems to perform a specific task. As you can see now, the operator actually grab a door and perform a specific movement with the door, and then we provided this data that have been generated from the Magos glove into a robotic system in order to perform the specific task. So whether that is important for the industry 4.0 industry, there are some specific in manufacturing industry. There are some specific areas of the in the production line that can be performed only from workers. This is because the high dexterity it's really important for these tasks. For example, this is a replica of a glass of a door for a car, and the positioning of this part is performed, as I mentioned, because of the dexterity and because the uh, the glass is pretty fragile. This task is performed only by workers. But what if you had a solution that could simulate and recreate this high dexterity and provide this data to a robotic system in order to automate also these parts of the production? And this is what CTAG from Spain tried to explore with our solution. This is another robotics project, mainly focused in the teleoperation of a robotic system for urgent events. So to be more specific here, if you can see on the left side of the screen, it's actually the virtual environment that the end user that you can see on the right side of the screen interact with. So you can see the digital twin of the whole environment. And the operator tries to teleoperate a robotic system that comprises a robotic platform, a robotic arm, and a gripper as an end offender remotely with the usage of Magos gloves. So that was another, let's say, application where we see that our technology could bring added value, since these interactions need high accuracy, and the system that can bring this accuracy into the table can create a leap into these applications on how you can teleoperate this type of robotic systems. This is the last demo that I would like to share with you before moving on to the questions. As you can see on the right side of the screen, here the operator can remotely teleoperate a robotic system. That was a project in collaboration with Siemens that they have a need for flexible manufacturing systems. These systems are really important for two main, let's say, reasons. The one is about uh, like the previous one use case to remotely teleoperate a robotic system, but in this particular case, having an added factor like a robotic anthropomorphic hand. But also, if they want to automate specific parts of the manufacturing line and production line, taking advantage of high dexterity interactions. So this is the presentation from my side. I would like to leave the rest time for questions. And Brad, if you'd like to let me know if there are questions from the audience, more than welcome to provide some feedback now. Brad, I'm sorry, I cannot hear you. You are muted.
I am so sorry. Okay. You on the SDK, there's a question on that. Is the SDK for certain headsets or is it like a generic OpenXR SDK?
It's an open at the moment since we've developed in Unity.
Hmm.
It's agnostic about headsets, and this is
Oh, good.
something that we from the early days we try to do in order to avoid these limitations about compatibility.
Yeah, that's good. Okay. That certainly makes it easier as a developer when you don't have to deal with too much
Indeed.
low level stuff. It's definitely cool to see it in the what was it, the intubation demo that you showed. It was interesting because when you watch the video, you could see him pick it up and then start to put it, and then he pulls back just a little bit, so you can definitely see that he definitely felt something there, which is
Yeah.
really powerful in training, I think.
Yeah, definitely. What we and this is a very good, example in order to provide uh, to elaborate more on this system part, because it's not we see endeavors that try to create something very good in a specific, area, but at the same time, we see that this type of solution is how can I say it? It's a very good trade-off at the end of the
Hmm.
day. You have to make hard decisions on what you have to make more sophisticated than other components in order to reach at a very good, let's say, final outcome.
Yeah.
And I think this is also the problem at the same time. It's the challenge that in order to find the best balance between hardware, software, but also in the application layer. I mean, in the game engine area and phase. So what we try to do with our solution is to create a very simple way to extract information from the hunt, and very simple algorithm that can restructure the hunt, the physical hunt, into virtual world. And
Yeah.
why this is really important? Because we don't have, a very high, let's say, level of computational power. We don't need high power for computational, and that provides us the capability to take advantage of the GPU and CPU resources, mainly about the interaction and what you just mentioned about the physics interaction. And this is what can, at the end of the day, can make the whole interaction more intuitive and more realistic in order to get the muscle memory required for such applications.
Question from the YouTube stream. On 0 to 10, can you give how confident you are that something like this will reach mainstream in the next couple of years over something like a glove? You've probably seen the gloves for haptic feedback.
Yeah. That's a great question. What we see at the moment from the industry that big corporates like Meta or Pico, everyone in the industry tries to create a solution that can provide this experience. So to move from the current virtual reality controllers to a glove type.
Hmm.
However, as I mentioned before, the biggest challenge here is to find the good trade-off. And just to make it even more clear before, uh, as I mentioned, the optical tracking is something that already we use in a daily basis. However, this interaction, even if you can use your hands, it's not better in some certain use cases compared to the controller, because controller can provide the haptic feedback at the end of the day. So even if you can use your hands, you don't have a vibration that can notify you that you grab something.
Yeah,
So what we see that the haptic and the force feedback make sense and are really necessary in certain use cases. So at the end of the day, I see that we are going to use every peripheral or every component out there based on the use case or the application that I'm going to consume.
yeah,
So down the road, after let's say 5 years, also in order to provide a response to the question, I see that we will have solutions like gloves or exoskeletons that are going to be very correlated to a specific use case.
yeah,
It's really difficult, I think it's really difficult to find a solution, at least for the next 5 years, that is going to be universal, that is going to be consumed for every application out there. So this is, I think, is the first step. Just to let you know, the restrictions that we face for a glove type solution is, from the commercialization point of view, is that if you go for a fabricated solution like a glove type, you have to purchase several sizes in order to address a specific
oh, I didn't even think of
use
that.
case. So
Another
what that
comment,
means,
another comment we got on YouTube was they're wondering how sore your fingers would feel after using them.
uh, so uh, in order to provide a good example here, is that all these solutions try to simulate the sense of touch. We haven't they're not simulate, they're not recreate the physical world. What that means, the tactile feedback, most of the solution utilizes vibrator sensors, where so what that means, that when you touch something, you get a notification that you touch a
Yeah,
surface. Or when it comes to force feedback, actually the subsystem applies forces and resistance to your fingers when you grab a solid component, a virtual object.
yeah,
So uh, so I have to say that this is not as you feel when you interact with the physical world. However, is a good trade-off when it comes to do things in a natural way within a virtual world. Uh, we see that there are some research in universities that try to make a more dynamic way between haptic and force feedback, but we don't have something concrete at the moment that is going to be the next generation solution that can take advantage of this research, let's say.
yeah. It's always an ongoing process, right?
Correct,
So,
absolutely.
so you did say about a month out you're gonna have a good kit. Is it like a dev kit that's coming out?
Yeah, at the moment, since we are a startup, uh, the alpha version that came up approximately 1.5 year ago, actually
Hmm.
we managed to collaborate with approximately 15 corporates around the world in order to get feedback and optimize the
Yeah,
system both in hardware and software, so you can understand to make the ergonomy, also the wearability more
yeah,
satisfying, but at the same time to improve the tracking and also the haptic feedback. So we managed to get this type of feedback in order to further optimize the system. Now we are really proud that we've reached the beta version that is going to be very close to the first commercial version.
okay,
So our goal is to, as you said, in 1 year, in 1 month from now, to proceed with the launch of beta version. Our expectation is to address approximately 100 and produce 100 pair of exoskeletons in order
nice.
to support the first 100 early adopters.
Okay. So, as developers, and there's probably a lot of developers that are in the audience, how would we go about if we were interested getting our hands on one of these?
Of course, they can reach out to our website where we have a form that in order to get the early access to our technology, but more than welcome to reach out directly to me and to my colleagues if they have specific, questions or considerations about how they could potentially integrate our solution into their applications. So there are, as I mentioned, several ways that they can communicate and reach out to us.
Awesome. Okay. This is exciting. It's always great to see the next step of what's coming, and then you can look a few years down the road and see you kind of get in your mind how it's going to evolve.
Yeah, that most definitely. We see that in this particular, path, you have to be patient and try to bring your to bring together several, sources of information in order to create something that can tackle or provide an added value. But at the same time, this is what we try to do
Yep.
compared to what we faced last year. So, I
Yeah.
mean, uh, trying to force the adoption of
Yeah.
such technologies. I think it's the other way. We have to explore the usage of these technologies in a way that, in order to create something that let's say, serve a specific pain point and provides added value to a specific problem, than going and create, solutions that are sexy and have fun, but at the end of the day, the investment that you have to provide, consistently, is it's very big, and the corporates have to have a very clear
Hmm.
strategy towards the end goal.
Yeah. It definitely comes across that you've got a passion for this. Otherwise,
Yeah,
I don't think you'd be able to stick it out for all these years to go from the idea to the glove with all the wires sticking out of it to
yeah.
finally a commercial product coming out.
Yeah. That's it. And for me, it was even worse, let's say, because I started from software,
Mhm.
software industry. So I had to get familiarized with several things that the deep tech requires, like 3D design, manufacturing, production, PCBs, electronics, all
Yeah,
this stuff,
yeah,
sensors, embedded software, in order to reach at the level where you are able to create software.
yeah.
So yeah, I think passion, as you mentioned, is something really important in order to start something that uh, even you don't know what you have to do. You have to experiment just the basics in order to reach
Yeah,
at the base level.
yeah. All those moments where you're like, "Why did I try to do this?" Yeah.
Yeah, yeah,
Awesome.
and
Well, Wasapo, thank you so much. This was a lot of fun. Very interesting.
Thank you so much once again, Brad, for the invitation, and was really excited about being part of this conference.
Yeah, it was great having you, and I can't wait to see what you do next. Have a good
That's
night.
great. Have a good night. Bye bye.